Hello and welcome to another episode of Momento Malum today. The global demands for major grains such as durum wheat are projected to increase substantially in the coming decades. This is driven by the ever-growing population's requirement for food and fuel. Canada is one of the major producers of durum wheat and other major grains. Canada provides a significant portion of the durum wheat for our international trade. For example, between 2016 and 2017, Canada produced 20% of the world's durum wheat. Dr. Lee of the AAFC wished to see how the cropping systems and agronomy of wheat has changed over time and how to improve going forward, and here are the results. Durum is mainly grown in the semi-arid brown and dark brown soil climatic zones of the Canadian Prairie region. The average grain yield of Canadian durum wheat during the era between 2001 and 2017 was 2.37 tons per hectare, ranging from 1.49 to 3.33 tons per hectare annually. During this time period, the overall durum wheat grain yields increased by an average of 70.2 kilograms per hectare per year. This improvement over the years is attributable to improvements in both genetics and management strategies. The largest producing province of durum is Saskatchewan. It is in this region where 1.8 million hectares of durum wheat are grown annually, with the total grain volume accounting for 84% of the total Canadian durum wheat production system. Saskatchewan is recognized worldwide as a consistent, reliable source of durum. However, the durum wheat cropping systems on the prairie face major problems. The first problem is moisture. The brown soil regions have an average moisture deficit of 250 and 400 millimeters per year of water. The climate of Saskatchewan is also very unstable and prone to unpredictable variation. The second challenge to durum wheat productivity in the prairie is the low soil fertility caused by low organic matter soils. And the third is a short growing season. In a normal year, the season starts in late April to early May and ends with the first frost in early September. Therefore, a seeding date is very important for many crops to mature, including the longer season durum wheat crop. The research found that the best planting date was between May 6th and May 20th. This prevents wheat from being hit by killing frost, improves establishment, and increases yield. The results of this early planting vary depending on the photosensitivity of this cultivar. On the Canadian prairies, durum wheat, similar to red spring wheat, was traditionally grown in a summer fallow followed by 2 cereal years, or continuous cereal system. In a summer fallow year, the land is left unplanted for the entire growing season. Summer fallowing practices have 2 major benefits for crop production. First, it conserves rainwater, whereby a portion of the rainfall during the summer fallowing period is reserved in the soil ready for next year's crop. Secondly, it allows for the release of available nitrogen from the soil. This comes with the drawback of fast decomposition of organic matter. This leads to a decrease in soil carbon and an increase in soil erosion, and an increase in nitrogen loss overall. This rotation has been replaced with a cereal cropping system. The legume in this instance is usually lentil or vetch. This rotation led to 19% increase in yield. The use of the legume crop also adds nitrogen to the soil through symbiotic nitrogen fixation. This reduces the need for fertilizer and increases soil carbon. Canola flax durum rotations are also found to increase yield in the wheat production. If you want to donate to my channel, the links are below. If you want to buy my book, you can also find that link in the description box below. On a genetic level, there's been efforts to improve grain yield, quality, and disease and insect resistance, as well as various agronomic traits. in Canadian durum wheat cultivars over the past century. Conventional selection methods and double haploid techniques have been used in durum wheat breeding, and it was found in durum that grain yield increased by 0.7 to 0.81% per year. This upward trend in grain yield did not appear uniform, and there was an acceleration event starting in the mid-90s. Several histories have been written on the cultivar development of Canadian durum wheat. Historically, the durum wheat cultivars, Wascana and Wokuma, were the predominant cultivars, occupying 70% of the durum area before 1987. This was changed with the release of the cultivar Kyle, which became the dominant cultivar by 1991, accounting for about 80% of the total durum wheat seeded area in Western Canada. This is because Kyle had greater grain yield, standability, and improved grain color in the presence of pre-harvest moisture. This cultivar was a challenge to surpass, but it was, and new durum wheat cultivars were developed, including AC Evelina and many others. AC Evelina became the most abundantly grown cultivar between 2005 and 2006 because of its higher grain yield and protein concentration. This lineage was quickly replaced by Strongfield, which combined the traits of high yield, high grain protein concentration, good standability, and strong gluten. In 2017, 3 cultivars accounted for 70% of Canadian durum being grown. These were Transcend, Strongfield, and Brigade. Transcend and Brigade were grown for their fusarium resistance and were important cultivars during that era. In time, higher yielding cultivars that would supersede Strongfield would take over, like DT881. Various breeding programs have been done to increase durability to aid biotic stresses. Several QTLs related to seed dormancy were found and incorporated into new cultivars to reduce pre-harvest sprouting of grain. The earliest cultivars of durum would also bioaccumulate cadmium, but it was discovered that it's a gene called CDU1 that is highly heritable and can prevent the uptake of cadmium without yield loss. The breeding for resistance to pathogens and insects is still among the top priorities for Canadian durum wheat production. As of 2018, all durum cultivars are resistant to the prevalent races of leaf rust and resistant or moderately resistant to the prevalent races of stem rust, stripe rust, and common bund. The exceptions to this rule are AAC Stronghold, which has intermediate resistance to common bund, and AAC Succeed, which has intermediate resistance to stripe rust. But one of the most important diseases and challenges in durum is fusarium. Although breeding for fusarium resistance in durum wheat began in the early 2000s, where there was some genetic variability in resistance to fusarium, the resistance was very low, and no cultivars of intermediate level resistance or higher were found, although Brigade and Transcend were used heavily to improve resistance. Several QTLs for fusarium have been identified in wild relatives of durum wheat, and ongoing efforts are occurring to transfer these traits into common durum wheat. Resistance to the pathogenic insect, orange wheat blossom midge, was found within the gene known as SM1. This gene is found naturally in bread wheat, and the SM1 gene was transferred from bread wheat to durum wheat using a long complex series of breeding systems. As a result, most modern cultivars have this gene now. As of 2018, no other genes have been found to confer resistance to midge. Single gene resistance traits are often short-lived due to selection pressure for path and pathogen strains that will overcome it. Consequently, a solution has been made to preserve the longevity of the SM1 gene. A stewardship plan has been implemented in Canada where 10% of the field has a susceptible cultivar. This provides refuge for the insect populations to reduce selection pressure for resistance. And that will covers everything. Thank you for watching.